Okay, let's do a few more problems illustrating circles. I want to start with, well, we can actually ignore 17. Which ones do I want to do? Oh yeah. Let's do this one. Okay, so let's look at something that's maybe be a bit more complicated for a circle. All right. This one says the figure shows two concentric circles, each with the center C. The larger circle has radius 14, the smaller has radius 6. Find all of these things. What would be the circumference of the larger circle, area of the smaller, area of the shaded? Okay, I would strongly recommend, pausing the video and see if you can solve this on your own. But I'm going to go through this relatively quickly. Think about if we're asked to find circumference, area, and area, we know what those formulas are. The circumference of a circle is 2 pi times whatever its radius is. The area of a circle is just pi r squared. Okay, so let's do the first one. What would be the circumference of the larger circle? Well, in order to answer that, all I need to know is what's the radius of that circle. Let's see. The larger circle has a radius of 14. Okay, well that's fast. That means the circumference of the larger circle is just 2 pi 14 or 28 pi. That's it. What about area of the smaller circle? Well, area of the small is pi r squared. Do we know what the radius is? Yes, we do. It says the radius is 6. So that's just going to be 36 pi. Hopefully these are rather fast. Okay, last thing. Area of the shaded region. Now, this is what might throw you a little bit, perhaps. But if you think about it, just look at this for a minute. Doesn't it look like it's the area of the larger circle minus the area of the smaller one? And that's all that we would have to do, is to find the area of the shaded region. Let's do Christmassy colors. It's, what is it? It's August, right? Yeah, don't feel like Christmas. Okay. Okay, so to find the area of the larger one, well, I'll kind of leave that as an exercise for you, but you could see that that would be 14 squared, that's the radius, times pi, minus 6 squared times pi. And whatever that is would be the area of the shaded portion. Okay, moving on. I kind of went fast, but let me know if this was confusing. All right, let's do some other ones here. Let's try some more complicated, perhaps, looking problems. Let's see what this. Now, let's talk about inscription. If something is inscribed in a circle, this is what this means. And I would always recommend making a sketch. You do this. If something is within a circle, it means that I've got some sort of shape, and I said that was a rectangle. Oops. Inside a circle, and when they say inscribed, it means all the corners would be touching the edges of the circle. Let's play this scenario out just for a moment. All right, it's a 5 by 12. So what that means is that this side length here is 5, and this side length here is 12. And the question is, what is the circumference of the circle? Well, we know what that is. The circumference of the circle is 2 pi r. We just need to figure out the radius. Once we know that, we're done. So let's see if we can do that. So the radius would be from the center to the edge, right? Something like this. That's the radius. But now just notice something. If I drag my line to, whoops, oh gosh, that was a little, you should probably just have used the straight line tool, but oh gosh, yeah, okay, I'm gonna, hold on. Yeah, let's just do that. This is getting sad. But if I drag a line, there we go, from corner to corner, notice what I just have right there. I know that this entire length here is the diagonal of this rectangle. So essentially, if you just kind of look at it, I'm basically trying to figure out what is the hypotenuse of this triangle inside, right? A triangle whose two lengths there are 12 and 5. I can use the Pythagorean theorem. I can figure out, well, 5 squared plus 12 squared is equal to 25 plus 144, which gets me to 169. You take the square root of that, and that should be 13. So I know that this entire length right here is 13. Well, but again, I just need to know what is the radius. Well, the radius would just be half of that because we went all the way across, so the radius would be 6.5. And yes, I know there's going to be those of you out there saying, well, but you found the diameter and it's just, circumference is diameter times pi. Yes, I know. For those of you that know that, yes, use that. But for the rest of us, radius. Okay? The radius is 6.5. Okay? Now, once I figure that out, just plug that into my problem, and it's just going to be 2 times pi times 6.5. Actually, okay, that just looked weird. But hopefully everybody would see, if you multiply that out, that the whole circumference would be 13 pi. And we're done. And that's it. Okay, let's try to do the last question real quickly. Let me pause the video and clear this up. Okay, it looks like we're back. Let's look at this one. Now, 25 is a complicated looking question, and I would encourage you to just try solving it by yourself for a moment, pausing the video. But here's the information we have. The radius of circle P is 3 times the radius of circle A. I don't think they wrote it down, but I think this is supposed to be circle A. Okay, so I know that the radius of circle P is 3 times whatever the radius of circle A is. Okay, they say the angles here are the same, but they don't tell us what they are, very importantly. Okay, so angles are same. Angles are equal each other. And then the shaded area of circle A, so the area of circle A is 3 pi, or the shaded portion, I should say. Then they want to know what's the area of this one. Okay, now, here's what I would suggest. In this case, the best solution would be, let's pick some numbers. Now, I don't think I would pick numbers for, think about what they did not tell us. They did not tell us what the radius is for either circle, and they did not tell us what the angles were for either circle. But they did tell us that, there's a relationship between the radius of one of them versus the other, and that the area of one, which we find by using the radius, is something that would make it a little bit difficult to pick a radius value that would fit for everything, just because there are relationships between them. Okay, but the one thing that we kind of have free game on is the angles. All they said about the angles is like, well, they're just the same. Let's try this. Let's say the angles are equal to 60 degrees in both cases. Let's see what happens there. Okay, let's try this. So this would be something we would plug our numbers in and see what we would get. All right, so if the angles are 60 and they say the shaded area is 3 pi, what would be the, let's back this up for a minute. In that case, what would be the total area? If the shaded area is 3 pi, given that we have 60 degrees, let's go, remember what our solution is here, is that we always figure out what's the total area, what's the fraction, right? And then the third step would be to find the area of the portion. It's just going to be total times the fraction. Okay? Well, starting with a small one. We know that the fraction is, if it's 60 degrees, that would be 60 out of 360. And again, we just randomly picked that number, but that's a nice, easy fraction to use. So that's 1/6. Okay? Hopefully everybody's with me on this point. So the fraction, we're going to just set that as 1/6. We know the total times the fraction has to be equal to 3 pi, because that's what they said, right? The shaded area of the smaller circle is 3 pi units. So think about it like this. Total, let's switch colors for a minute. The total area times 1/6 has to be equal to 3 pi. Well, what would that be then? What would the total have to be? Well, we could multiply both sides by 6, and we end up getting total is equal to 18 pi. So far, so good. Well, but then think about this. This is the total area of the small triangle, the small circle. What would the radius have to be if this is true? The total is equal to 18 pi, and we know that the area of a circle is equal to pi r squared. Well, that would mean the total of the radius of the small circle has to be square root of 18. Okay? Just bear with me on that. Hopefully, pause the video if that confused you, but this is what we got. We always have to figure out radius, right? That is the goal with circles. What is the radius? Okay, so in this scenario, if the angle is 60 degrees, the radius has to be, for the small triangle, I keep saying triangle, the small circle has to be root 18. Okay, now let me clear this up for a moment. Let's take that out. Now, then that means, okay, so now that if I know that, and then it shouldn't be too terrible to do the rest of this, because look at this. The question is, what's the area of the shaded part of the bigger circle? Well, we know that that's just going to be the total area of the bigger circle times the fraction. Actually, I shouldn't have used, sorry, bigger circle. So that's circle P, right? Total area of circle P times the fraction of circle P, and that would be equal to the shaded portion. That's what we're trying to figure out. Well, I do know the fraction. They said the angles were the same, so the fraction is 1/6 in our scenario. And okay, now this is the hard part. What is going to be the total area? Well, we know that the radius of the big circle is 3 times the radius of the smaller circle. Well, if the radius of the smaller circle is root 18, 3 times that is 3 root 18. Hope everybody's with me. Okay, so then find the area. It's just the radius is squared, so we just square that and multiply that times pi. Times pi. Well, what would this be squared? Well, 3 squared is 9. 18 squared is 18, because root 18, well, root 18 times root 18 is just 18. So we have 9 times 18 times pi. And that's what that is. Oh, this is getting long. Oh, gosh. I think you kind of get the idea from here, but let's just quickly see if we can finish this off. 9 times 18 is equal to 162. So the total, total area would be 162. Pi times 1/6. The fraction would be, what is this going to be? 162 times, well, actually, hold on, times 1. Hold on a second. Whoops, what did I just do? Never mind. 162 divided by 6 gets us to 27 pi would be the area of the fraction. Now, you can check this, and it will turn out that no matter what numbers you pick, the only thing that we picked was what would the original angle have to be. But try this again and say, try pick your initial angle being 30 degrees and do exactly what I just did. And I think you'll find that you're going to get the exact same result. So the key takeaway here is with this kind of a question, pick a value to start with, plug in your numbers. Always with circles, you're trying to find your radius. Go from there. Hopefully this was helpful.